Hey everybody, I want to spend a few minutes going over some conversions and calculations examples, specifically how to convert from one unit of pressure to a new unit of pressure. And then we're going to look at Boyle's law, which relates pressure and volume. So the first couple examples are pressure conversions. And you need to be familiar with your pressure conversions. They're also on your reference chart. Know that standard pressure is 1 atmosphere, which is also equivalent to 760 millimeters of mercury, which is also equal to 101.3 kilopascals, kPa. So standard pressure are these conversion factors right here. Okay? So in example 1, it says convert 785 millimeters of mercury to atmospheres. So what I'm going to do here is I'm going to zoom in a little bit. Okay, so what we're doing is essentially dimensional analysis. You're going to use your T-chart. So like we've practiced before, you're going to identify what information is given to you. In this case, I'm given 785 millimeters of mercury, and I want to convert to atmospheres, which is my unknown. So I'm going to start my T-chart with what information is given to me, which is 785 millimeters of mercury. Set up your T-chart. Now I'm going to bring down the unit, millimeters of mercury, and I'm converting to my unknown, which is atmospheres. So now I look up at my conversion factors. 1 atm equals 760 millimeters of mercury, which equals 101.3 kilopascals. So look at what you are given and what you're trying to convert to. I need millimeters of mercury and atmospheres. So in this conversion factor, I'm only looking at atmospheres and millimeters of mercury. So where I have atmospheres, I'm going to write a 1, and where I have millimeters of mercury, I'm going to write 760. So 760. So 1 atmosphere is equivalent to 760 millimeters of mercury. So now I calculate 785 times 1, all divided by 760. Gives me approximately 1.03. 1.03 atmospheres. So what this says is 785 millimeters of mercury is equivalent to 1.03 atmospheres. So let's try another one. Number 2 says express the pressure 785 millimeters of mercury in kPa, kilopascals. So identify what's given to you. Now I'm given 785 millimeters of mercury, and I'm converting to kilopascals. So dimensional analysis will say that my given information, 785, goes first, T-chart, bring down your units, millimeters of mercury, and what you are converting to, kilopascals. So now I refer to my conversion factor. 1 atmosphere equals 760 millimeters of mercury equals 101.3 kPa. I'm only concerned about kPa and millimeters of mercury. So kPa is 101.3 and millimeters of mercury is 760. So now I calculate 785 times 101.3 divided by 760. That gives me 104.63 approximately kilopascals. So just a one-step dimensional analysis. So the next couple examples are relating to Boyle's law. And Boyle's law shows relationships between pressure and volume. And what you need to understand is that there's an inverse relationship between pressure and volume. So what does that mean? Well, that means as the pressure in a container increases, then its volume will do the opposite. This is an inverse relationship. So as the pressure increases, volume decreases. If the volume increases, then pressure does the opposite. Okay? So as a gas is pushed down and compressed, the pressure is increasing. As a result, that gas now occupies less space and the volume has now decreased. So what does that look like in the form of a graph? Well, I can compare. Let me try to draw a better one here. I can compare pressure and volume. Say if I got pressure on the X and volume on the Y. Normally, if this is 0, as I move to the right on my x-axis, my pressure, or any value, normally increases. As I move up the y-axis, my values also increase. So if this is true, if pressure and volume are inversely related, then I need to see a graph where the pressure increases and the volume decreases at the same time. So if I move to the right along my x-axis and my pressure is increasing, then while I'm moving this way on my x, then my y values have to decrease. So that looks something like this on a graph. This is an inverse relationship. This is a negative slope. So how does that translate to calculations? Well, let's take a look. So like you saw up above, and I'll rewrite it here, that P1 V1 equals P2 V2. So the original pressure and volume is being compared to the new pressure and new volume of the same gas at the same temperature. So example 3 says a gas has a pressure of 1.26 atmospheres and occupies a volume of 7.4 liters. If the gas is compressed to a volume of 2.93 liters, what will the resulting pressure be? So the first thing that you should see here is the pressure. It's telling you the pressure of a gas is 1.26 atmospheres. So that's my original pressure. I'll label this P1. And it occupies, that same gas occupies a volume of 7.4 liters. So that's the volume of that same gas. So now it's telling you the gas is being compressed to the volume of 2.93 liters. So now this is my new volume. I want to know what the resulting pressure is going to be. So in other words, you are trying to find P2, the new pressure. Okay, so let's take a look at this. If my pressure is 1.26, my volume is 7.4. I don't know the new pressure, but I do know the new volume. So your volume is going from 7.4 to 2.93. So in other words, your volume is decreasing. So if volume and pressure have an inverse relationship, then that means that if your volume is decreasing, then your pressure has to be increasing. Okay? So my volume decreased. If my pressure is increasing, that means if I start at 1.26, this new pressure has to be greater than 1.26. Anything less than 1.26 can be thrown out or marked incorrect because you know this relationship is true. So your resulting pressure must be greater than 1.26. So let's figure out what that looks like. So P1 V1 equals P2 V2. So your original pressure is 1.26 atmospheres. Your original volume is 7.40 liters equals your new pressure is unknown, but your new volume is known to be 2.93 liters. So I'm going to go ahead and combine like terms over here on the right. So when I multiply 1.26 by 7.4, I get 9.324 equals P2, and basically everything that's still on the right, 2.93 liters. So I want to get P2 by itself, so that means I need to do the opposite operation, which is to divide both sides by 2.93. And that means this cancels on the right. And P2 is equal to 9.324 divided by 2.93, which gives me 3.18 approximately. And my units for pressure are atmospheres. So just like we mentioned, if the volume is decreasing, went from 7.4 to 2.93, based off of the relationship in Boyle's law, that means my pressure has to increase. So it has to be greater than 1.26, and 3.18 is certainly greater than 1.26. Let's look at our last example here. Example 4, it says, if the pressure on a balloon with a volume of 300 milliliters increases from a standard pressure to 2.5 atmospheres, calculate the new volume. So let's see, it says the pressure on a balloon with a volume of 300 milliliters. So it's telling you what the volume is. This is the original volume. We'll call this V1. It's increased from standard pressure. So from standard pressure. So what is standard pressure? Well, standard pressure is 1 atmosphere. So this is the original pressure. So how do you know it's 1 atmosphere? Well, I know standard pressure can be either 1 atmosphere, it could be 760 millimeters of mercury, or it could be 101.3 kilopascals. So how do you know which one it is? Well, when I look at the new pressure, 2.5, the unit is in atmospheres. So that means the starting pressure must also be in atmospheres. So standard pressure in atmospheres is 1. So P1 has a value of 1. So let's continue on. So it's starting at standard pressure, which is 1, and it's increasing to 2.5. So this is my new pressure. I want to calculate the new volume, which is V2. So let's take a look at it. I've got a starting pressure at 1 atmosphere, and it's increasing to 2.5. So your pressure is increasing. Based off of Boyle's law, if the pressure goes up, that means your volume has to go down. So that means if my starting volume is 300, my new volume has to be something less than 300. If your volume that you calculate is greater than 300, or you have an answer choice that is greater than 300, you could automatically throw that out or recalculate. Based off of Boyle's law, if my pressure is increasing from 1 to 2.5, so it's increasing by 2.5 times, that means my volume has to decrease by 2.5 times. So let's find out if that's true. So Boyle's law says P1 V1 equals P2 V2. So the value of P1 is 1 atmosphere. The volume of V1 is 300 milliliters. The value of P2 is 2.5 atmospheres. And the new volume is unknown. So now I'm going to combine like terms on the left. 1 times 300 is simply just 300. And on the right, I still have 2.5 times V2. So in order to get V2 by itself, I'm going to divide both sides by 2.5. And 2.5 cancels out, which gives me my new volume all by itself. So 300 divided by 2.5 gives me 120 milliliters. So just like we mentioned, if my pressure is increasing from 1 to 2.5, then that means my volume has to decrease by 2.5 times as well. And sure enough, it started at 300 and it is decreasing to 120 milliliters.